All right, so let's take a look at this lesson, 6.3. It says proofs of parallelograms. Don't be scared off by this. We're not going to do any proofs. You probably don't even know what a real proof is anyway. And if you did, you'd be very, very, very glad that we don't do proofs in here. All right. So some geometry teachers would just shake their head and say, I can't believe you don't do proofs in a geometry class. Just like I always say, you should have known this, in ninth or in your Algebra 1 class. Some geometry teachers would probably get really upset with me if I didn't do proofs. But I got other things I need to teach in here, all right? And proofs, just be glad, okay? You should be very, very happy with me that I don't teach proofs. Anyway, with all that said, we are going to talk about a few things. Let's review very, very briefly. Before I started recording, I just kind of asked you some questions. Let's do this. Let's make it look like a parallelogram. This is all about parallelograms, by the way. All right, so there's parallelogram. So here's the difference. This is the key difference between what we're learning today and what we learned the last section on 6.2, okay? I'm starting off telling you it's given, okay? That means they tell you this stuff, all right? It's given that this is a parallelogram. This is the old way, all right? It's given that you have a parallelogram ABCD. All right, so in section 6.2, that's what they did. They said, okay, this is a parallelogram. So we went through it earlier. Let's do it again. What's true about AB and DC? If this is a parallelogram, if they told us that this is a parallelogram, what must be true about AB and DC? They're equal to each other. What's true about AD and BC? They're the same. They're equal to each other, correct? All right. You also know they're parallel to each other, right? Right? AB and DC are parallel. AD and BC are parallel. You know that. What do you know about, did we do all the sides? AD, BC, did I say that? Yeah, both pairs of opposite sides are equal to each other. What do I know about the angles? What do I know about angle A and angle C? If this is a parallelogram, what do I know about those two angles? They're equal. What do I know about B and D? They're equal. What do I know about A and D? They're supplementary, which means they do what? They add up to 180. What do I know about A and B? Supplementary. B and C. Supplementary. D and C. Supplementary. All right. We pretty much covered it. What if I had diagonals in here? Okay, I don't have them right now, but what if I have diagonals in here? If this is a parallelogram, listen to me. This is the difference between what we did earlier and what we're doing today. Before, in 6.2, they told you it was a parallelogram. If they told you it was a parallelogram, then I could tell you a bunch of stuff about it. I could tell you all the opposite sides are equal, all the opposite angles are equal, consecutive angles are supplementary, blah, blah, blah. All this stuff we just talked about. But I could also tell you something about the diagonals. What's true about BD? No, I shouldn't say that. I lied. What's true about DX and XB? They're equal to each other. So that little bit right there and that little bit are equal. Why? Because that diagonal is being what? Bisected. That's right. It's being split in what? Half. Got it. What about AX and XC? They're equal to each other. Does that mean the diagonals are equal to each other? Does that mean that AC and BD are equal to each other? No. AC definitely looks shorter, doesn't it, than BD? And it is. All right? So it doesn't mean the diagonals are equal to each other, but it does mean that the diagonals bisect each other. And we know all this stuff. Why? Why do we know all that stuff? Because we were told that this thing was a what? Parallelogram. Okay? Have I made that clear? We started off knowing that it's a parallelogram. Now, watch this. Tell you what, let me just copy that and paste it. There we go. All right. Right now, this picture right here, if I didn't tell you anything about that picture, can you say that that's a parallelogram? You can't, because you don't know anything about it. First of all, they didn't tell you it was a parallelogram, correct? You can't just look at it and say, it looks like one. It looks like a parallelogram. But do I know for a fact that that's a parallelogram right now? No, I don't. Okay? But watch this. What if I told you, okay, listen, I did not tell you that this was a parallelogram. Everybody got it? Okay, I'm not saying it's not a parallelogram. I'm just not saying anything about it. But what if I told you that this side was equal to this side, and because just knowing that doesn't say that that's a parallelogram. But if I know that this side and this side are equal, and if I knew that this side and this side were equal, then do I have enough information to say something about this figure, this quadrilateral? What do you think I could say now about this thing? If the two opposite sides are equal to each other, then this thing is probably a what? A parallelogram. Do you see the difference? Okay, so before today, before this last minute, there is no way that you could have said that that was a parallelogram. But now that if these two sides are equal and these two sides are equal, that's enough to say that this is a parallelogram. You see the difference? I didn't tell you it was a parallelogram to begin with, but then I started telling you some stuff about it. I told you that these two are equal and these two are equal. That's enough to say that that's a parallelogram. So now, what can I say about this? This thing is now a what? A parallelogram. Exactly right. Okay? You see it? I told you I was going to repeat stuff about a dozen times, and I'm going to... This is the beginning of it. All right? What if I had this? What if I told you... Now, this is a little bit different. What if I told you that these two sides were parallel to each other? Is that enough to say that this is a parallelogram? No. Okay? Now, it could be a trapezoid, couldn't it? Because remember we had a trapezoid where only one pair of opposite sides were parallel? Remember that? Okay? So I'm not sure right now if this is a parallelogram or not. Now, if I told you this, now what is this thing? Now it's a parallelogram, okay? Because when both pairs of opposite sides are parallel, that means it's a parallelogram. Well, check this out. There's one more thing. We didn't really discuss this earlier, but what if you had these two were parallel and the same exact parallel sides were also equal to each other? That's enough to say, guess what? That this thing is a parallelogram. Are you with me? So I'm giving you information. I'm saying, is this enough information to say that this is a parallelogram? Yes, it is. This is one of our theorems, okay? I'm not writing down the theorem. I got it in my notes. Look, see, I got all those words for my theorem, okay? So I'm not writing it down, but I'm just showing you the pictures just so you know what's a parallelogram. So if both pairs of opposite sides are equal to each other, then guess what this is? This is a what? This is a parallelogram. What if I told you had a four-sided figure and one set of sides, opposite sides, were parallel, and those same set of opposite sides were also equal to each other? What is that thing then? That's a parallelogram. It's kind of on a roll, but I'm going to stop here for a second. Watch. What if I told you that this and this were equal? Does that make that a parallelogram? What word did I use earlier? What other shape did I throw into the mix here? Trapezoid. So look, does this make that a parallelogram? No, it doesn't, because check this out. What if I had this? Those two are parallel, correct? Okay. They're definitely not equal to each other, right? And these two are equal to each other. Is that a parallelogram? No, it's not. So, what if these two sides right here were equal? Does that make that a parallelogram? No. What makes it a parallelogram? They're parallel and what? Equal. So all I need are one set of sides. I don't have to know anything about this side and this side. If these two sides right here are parallel and equal to each other, then this is a what? A parallelogram. All right? So it has to be the two sides that are parallel to each other are also equal to each other. That's enough to say that it's a parallelogram. All right? You're kind of getting the idea now, aren't you? What if, and you probably know where I'm going with this, what if I told you that this angle and this angle were equal, and this angle and this angle were equal? So what if I told you that both pairs of opposite angles are equal to each other? What do you think this thing is? It's a parallelogram. Exactly right. Do you see the difference? The difference is before we said, okay, this is a parallelogram, so what must be true about it? The opposite angles must be equal, right? Now what are we doing? We're saying, okay, you got this four-sided figure, this quadrilateral. I don't know it's a parallelogram just yet, but I do know that the opposite angles are equal to each other. What does that make that thing then? It makes it a parallelogram. So, with that information, what is this thing? This is a parallelogram. You should be able to spell this by now out of all the times I'm writing that down. All right? And we got, let's see, one more. Just the two more. Okay? Watch this. What haven't we used just yet on this? Diagonals, right? So let's throw some diagonals in there. So watch this. Just putting diagonals in there, does that make this a parallelogram? No. I could put diagonals in a trapezoid, all right? But just because they're diagonals does not mean this is a parallelogram. But what do you think must be true about the diagonals in order for it to be a parallelogram? Does anybody keep count of how many times I say parallelogram today? It seems like I'm about to up to 50 now. Okay. So what must be true about the diagonals?
Equal.
Well, not the diagonals are not equal to each other. They bisect each other. Okay, let's say it this way. If they bisect each other, then this thing is a what? Parallelogram. So if I knew that this and this were equal, now if that's all I knew, you couldn't say it's a parallelogram. Okay? But if these two are equal and at the same time these two are equal, then what's that whole entire thing? It's a parallelogram. Okay? Do you see the subtle difference between what we did before and what we're doing today? Before, they told us it was a parallelogram, and then we knew all this stuff was true about it. Today, we know all this stuff is true about it, and that makes it a what? A parallelogram. We good? All right, got a couple examples. Definitely not going to be able to hit them all. We'll barely be able to hit any of them. But we'll give it a shot. Okay, we're going to work all the way till the bell rings here. Let's put a little slant to this. Everybody hang with me. Don't pack up. We're not finished. I did not say we're finished. All right, what if you got something like this? And what if I told you what if I told you that this and this were equal, and this was 108, and this was 72? All right, here's the key. Watch. Bell's about to ring, but pay attention. These are supplementary, aren't they? But I didn't have any theorem that talked about the angles being supplementary. But check this out. If they're supplementary, what does that mean about this side and this side? They must be what? Parallel. So now, is this thing a parallelogram or not? With the information. Yes, it is. And that's the kind of stuff that they're going to ask you to do. I guess there's no homework. We still got a few more things we got to go through. If I would have had a few extra minutes, could have had it done.